Hello, everyone. I'm Serge, and this talk is going to be giving you insights how you can build practical, automated, distributed data mesh with Databricks and Terraform. So, briefly about me. I'm Serge. I worked as senior specialist solutions architect at Databricks, and I am the lead maintainer of Terraform integration. So I've been working in the old stages of data lifecycle for the past 15 years, and I've been building a couple of data science platforms from scratch, and been there, done that, and I want to share all of this knowledge with you. So let me show you a story about a typical customer who starts using Databricks. They create a job that reads data somewhere from internal APIs, and then it writes somewhere to a storage mounts, and then creates another job to ingest data from somewhere else. And it goes on and on and on. And in a couple of months, a customer gets like 50 jobs. Then a customer grows, and more things are added to their workspaces. They finally start using better configuration practices, and their API keys are stored in secret scopes, and they start to add permissions to everything so that they can add the on-call group, they can add billing group, they start to do cost optimization with instance pools, and they expose their data lake through shared auto-scaling cluster in their workspace. Well, yeah, nice. But then suddenly, later down the road, they're getting requirements about data locality, and their project matures. They have to add audit logs, and they need to start monitoring, and they start to get IP access lists added. Ooh, yes. Eventually, the project is duplicated across 50 different regions or 50 different teams. And yeah, it resembles something. Yeah, it's a typical scenario for a distributed data mesh where you have something similar as the core for the data platform that's replicated many, many, many times in order to ensure consistency. And in a year, you have a pretty big thing. So you may have read about distributed data mesh on Martin Fowler's blog. Here's a picture from it. And this is really about different groups of people managing their data. And it's about people over processes and concepts and patterns that you implement tailored to your organization. And what you'll see, data infrastructure as a platform in the bottom of this picture. Because if you don't have a central team that manages the governance, that manages data platform as a service, that manages this infrastructure, distributed data mesh would simply turn into a big mess. And Databricks with Terraform is the foundation of dozen distributed data meshes I've seen so far. And this talk will be exactly about not so much discussed aspects of how you do data mesh in practice, how you make sure that your automation is working well, scales among dozens of people or hundreds of people, and doesn't take up too much of time from anyone. So here are some basics of Terraform for you. It's infrastructure as a code, which is literally like HTML, but for the cloud. And we are the infrastructure for data and AI in the cloud. This way, we can make it repeatable, auditable, and multi-cloud. Here you can see the live demo using the following in action. And it's used to provide consistency across multiple clouds and environments. It's a key enabler for expansion because it has authoritative state that requires less tribal knowledge, and you can do peer review changes. Whenever people edit it through Git, they can safely apply those changes to production. It has a robust support for all entities in Databricks. Unity Catalog, MLOps-related entities, jobs, workflows, permissions on data, on objects, you have it all. And Terraform for cloud infrastructure is literally like Spark for data. Keep that in mind. So this way, you can really scale your CI/CD processes and be happy about it. It has excellent product documentation, rolled out and versioned with each release. So everyone can get started and find it on the registry Terraform.io. And all of the necessary information over there is linked. Databricks Terraform integration is now generally available. It has been battle tested for more than 2 years in Databricks labs since April 2020. The adoption grew by more than 100 times, and it actually became top 5% biggest Terraform providers overall by size, installations, and contributors. It has 4 million downloads or something. And you can also adopt it very, very fast. Fear not. If you have an existing workspace that you have created manually, and you want to automate that workspace, because essentially that's why you're attending this talk. You want to automate your distributed data mesh in an easy way. So if you have your existing Databricks workspace, there is an experimental resource exporter that can generate some of the code for almost all resources in your workspace, which you'll later take and tune for more maintainability. And this tooling is usually used for preparation of disaster recovery exercises. Now, there are many levels where you do automation. And the easy way to look about it is to think about micro level and macro level of automation. Macro level includes network boundary setup like private link, IP access lists, private networks, and etc. It also goes all the way down to management of permissions on data through Unity Catalog or table access control lists, down to tables, schemas, and catalogs, and many other things. Micro level includes management of your workloads, like jobs, clusters, and other specific things. So let's look at some of the micro level automation setup. Let's say you want to create a job that has an API connection that you need to read data from or send notifications in the end of the job. And typical thing you want to do over there is to have a password to that external service. So what do? If you're coming from classical software engineering setups, you might think, hey, why just not creating a local file that is read from file system through JSON? Well, of course, you can do that, but you totally shouldn't. You totally mustn't, because it's cloud, and relying on a local file system in the cloud is not so good. And besides, there is password. And password, you cannot store in the clear text because it's a security risk. Also, if you store a password in the configuration file just like that, it could be accidentally printed. That's also not what you want. So there are a couple of alternatives to configuring jobs, like passing down parameters through notebook task parameters. Well, you can read notebook task parameters through dbutils widgets get function in a notebook, and so you can have some sort of interactive dropdowns, interactive inputs in a notebook, and automate it all. Well, it's good for some things. If you want to parameterize the dashboard, yeah. But don't use it for passwords, because passwords would be printed in clear text, also in the job config, as you see. You can also pass down the command line arguments into Python scripts. Like if you have an existing legacy application written in Python, written with open source Apache Spark, that you want to just put and run on Databricks, and it takes command line arguments, yeah, you can use the command line parameters through Spark Python task, it will work. But do not pass passwords over there because it will be printed in the clear text. What you should do instead, and the best way to pass down passwords, should be implemented with secret scopes. Because you can pass down secret scope references as Spark configuration to a job. So that application code reads any configuration through Spark conf get helper function, regardless whether or not the data within that configuration is secret or not. And using secrets give you a great benefit of secret redaction as a protection from accidental printing. So bottom line, how you should build configuration for your workloads is that you use SparkConf, you pass down all of the environment-specific configuration through SparkConf, including secrets. This way, it's easy to develop locally, and it's easy to be sure that your passwords are not printed. Now, let's talk about macro level. One of the teams at Databricks started working on automated reusable building blocks for machine learning operations, which we've open sourced after extensive internal trials, and you should check this out at Terraform registry. Like these modules create and configure things like service principals with appropriate permissions to running your CI/CD workloads, and create workspace directories with multi-workspace staging, dev production setups with the centralized model registry, et cetera, et cetera, et cetera. These things are not easy to do by hand and hard to get right. And these modules will help you to get started and adapt them to your workloads. And you'll have a full, proper automation for your MLOps setup. You can take a picture of this. So the main link you should pay attention is registry, Terraform.io, namespace is Databricks. That's the place you should be looking at. And you'll discover the documentation for Databricks provider as well as modules. I would not be talking more about MLOps because it's a credit for the other team. Now, let's look how you build a very typical scenario for a distributed data mesh. Like, why have data mesh in the first place? You want to give full control to your people, still having a control of the environment you run. Because if you give people too much control, you may end up in a situation of data scientists deleting production data or running over the costs more than needed, like 100 times or something. And your goal as the leader of your data platform is to keep everything stable, manageable. But the main thing you want is also to keep your data scientists and data engineers happy. So what you do? You take all users in a workspace and give everyone a checkout of the main Git repository, assuming you have one workspace per project. And then for this Git repository checkout, you create a job. And you give ownership rights to every user to their own job. And you also add on-call group that you should have in your mature platform to restart jobs, kill jobs, tune jobs whenever it's needed. So that with these 50 lines of code of configuration, you actually roll out exactly same job setup for teams of 10, 20, 50, 100 people so that they can work independently in relative isolation from each other and innovate, and produce more results. Because this data mesh is the primary goal. You need to give people the ability to innovate without stepping on each other's toes. Here's the enablement for it. The other typical use case is related to platform library management. Like, you have some shared libraries, like jars, that you have to install by compliance on all of the clusters. So what you do, you create a jar, put it on the BFS, And with this 10 lines of configuration code, you just install it on all of the clusters, having it very easy. The other interesting pattern that I highly promote is related to extendable cluster policies. Very applicable to self-service teams. So if you don't know about cluster policies feature of Databricks, it's a way to empower data scientists and data engineers to create their own clusters without giving them the administrative rights on a Databricks workspace. And besides of giving them rights to create clusters and not giving them admin, you can impose certain restrictions, like making sure that every cluster created by this group of users has its auto-termination settings turned on. Because, like, please raise your hands. Like, who experienced high costs of running interactive cluster by forgetting to turn the cluster off when it was not in use? Oh yeah, I see half of the hands. So essentially, for the other half who didn't experience that, if you don't know about the auto-termination minute setting in the Databricks workspace, this is the ultimately life-saving property. So make sure to set it as much as possible and everywhere you can. And the easiest way to set it is through Databricks cluster policies. The other thing you can put into common cluster policy template is the cost center tag. So that's your finance department would know how much your department, how much your group, how much your team within data science consumed in terms of cloud cost. Because generally, if you don't enforce the same tag for the team, it becomes a mess in terms of billing reporting, either through Amazon Cost Center or through Azure Cost Center or Google Cost Center. So please make sure that you have the same tag set for all of your Databricks clusters, and you are able to break down the cost by team. And then, once you have this common module with common settings, you can easily scale it out to 1, 2, 5, 10, 20, 100 different teams. Because essentially you have your baseline cluster policy, and then you may extend it on case-by-case basis for different teams. For example, marketing department will have this amount of cluster settings through SparkConf. Then engineering department will have higher quotas for DBU per hour than the support department, and so on, and so on, and so on. Your imagination is the limit. Well, and abilities of cluster policy also is the limit. So you can see the sample in Terraform registry documentation for Databricks cluster policy resource. So know it exists, and when you are rolling out freeform, self-service, data mesh, you should have cluster policy. And my recommendation is to define it in a way that resembles this slide. So bottom line, use cluster policies. They are lifesavers. Now, the other common pattern for a distributed data mesh is actually a secure bucket or secure storage location. Essentially, it's cloud provider's security policy applied automatically and used for mounting the storage on a Databricks workspace. Because essentially, what you want is to have a bucket policy attached to a cross-account policy that allows Databricks to pass given a list of roles, and then allow Databricks platform to do actions on your behalf, and you have to add it to cross-account role, and you have to register this as instance profile in Databricks, and you have to mount, and you have to wait for mount to be working and sane, and so on and so on. Essentially, setting these things up manually takes like, 1 hour, like 20 minutes if you're really good at it, but it takes like literally 5 minutes to do this automatically. So make sure to automate these very important things like secure buckets. because it's a very repetitive thing. Because at the early stage of your data journey, you may have like 1, 2 buckets, but like in the end of your data maturity, you may be creating a bucket per project, and you may have hundreds of projects, even in a small company. So like automate as much as possible. Though the best way to roll out secure data access is through Unity Catalog, which adds a perfect and easy way of managing access over catalogs, schemas, tables, and so on. And this is great, because terraforming Unity Catalog allows you to keep all of the permissions control under the same code base for infrastructure as a code. This is quite common, and if you have a very strict requirements for your security, and you have auditors, for example, you show them, hey, here's Terraform code that manages permissions for all of the row level, or table level, or cluster level, or whatever other level permissions. And they're like, oh, whoa, nice. This is quite readable and quite manageable on large scale. Like, tell me, like, is permissions management a pain in your organization at the moment? Please raise your hands. Quite some hands. Nice. So the other thing you may think about now is like, hey, what about development environments for data? Like maybe every developer would want their own development schema, or maybe every developer would want their own catalog. It's quite easily possible with automation like Terraform, and the limits are only defined by capabilities of your imagination. So using automation as mature as Terraform, you can scale out to many new use cases you haven't even thought about yet. Another common pattern of using infrastructure as code is disaster recovery ready setups, which usually involve 2 separate Databricks workspaces that are rolled out in 2 different regions. And whenever you deploy any configuration change, you deploy to both of them at the same time. And for data, you also keep 2 storage locations that are synchronized through Delta deep cloning functionality that does it consistently. If you don't know about deep clone, read about it. It's quite cool. So essentially, in the disaster event, whenever the region is unavailable for some reasons, like, I don't know, you cannot spin up more VMs, or other things happen, just switch to using the other workspace that is exact carbon copy of the primary one. Quite nice, and works with many different customers. And fear not, you don't have to write all of the configuration by hand if you have existing Databricks workspace. Because remember, you can use Terraform exporter that generates the configurations for you, and so you have to just tune it by hand to make it a bit more readable, because you can do as much in config generation. Then another common pattern I'm seeing is related to user management, because sometimes standard user management tooling does not work for various different reasons. Like either because you have a very strict networking setup and identity provider cannot reach out to your workspace through SCIM protocol, or you're required to use Azure Active Directory tokens by a compliance and cannot use personal access tokens of Databricks, or you just don't have access to your identity provider as workspace admin because, yeah, you're a data engineer. You want to spin up a Databricks workspace for 100 data scientists, and you don't want to go through all of the Active Directory setup. So essentially what you do, you just manage users through Terraform. I'm like surprised. Yeah, we have these beautiful SCIM synchronization capabilities, but people use still Terraform for managing users and groups and memberships. And this is actually quite high in the usage list. Then the other patterns, like project-based workspaces. For example, you gather a team, You spin up a workspace. You add some specific configurations to a project, like security, cluster policies, secure buckets, and so on. You invite people in. Then people do the work for 1 week, 1 month, or half a year. And then once project is done, you just tear it down with all of the related infrastructure. Like, this pattern is used by Databricks Academy, where for every instructor-led training, you have a dedicated workspace. This pattern is also used by many different customers in different industries as a mean for having an isolated group of people to work on a certain thing, and so on and so on. The other common pattern is related to code artifacts, essentially by putting libraries into mounts, synchronizing them instead of using private repositories. And then there are different patterns for networking, like setting up private link, setting up Azure VNet injections, and so on. Please make sure to search for a Databricks provider on Terraform registry, and you'll find those as guides, because we are working on making those guides extensible, easy to consume, readable, and tutorial-like. So they're great. We have a guide for Amazon Private Link. We have a guide for data exfiltration protection setup. We have guides for setting up private VPCs in a fully automated way, et cetera, et cetera, et cetera. So you'll be amazed when you visit that, if you didn't already. Now you may ask how I can use this. Like, typical way of deploying it, typical way of using Terraform is through Git automation tooling tied with your version control, like GitHub Actions or Azure DevOps pipelines, and you use manual approval step in between. And you can find actually example in Terraform Databricks example repository in Databricks GitHub org. The other common way of running infrastructure as code in production is through Terraform Cloud or Terraform Enterprise. It's a bit easier than GitHub Actions or the Azure DevOps pipelines, and you can actually get started within like 20 minutes to get your continuous deployment pipeline ready. And yeah, I hope you've learned some things. And if you have questions, I'll let Manish to coordinate that.
Hi. So this question is around disaster recovery. So assume one region goes down. We use infra as a code to bring up the workspaces in the other region. But how does the metadata, how does the notebook, which are stored in the Databricks side, get carried forward to the new infra we brought up?
Yeah, so for disaster, so the question is, how do you keep the metadata of which region in disaster recovery is actually active or not? So you have to build it yourself, and the metadata about active region should live in the Terraform state. And usually this metadata is also switched for your business intelligence tooling. And you may find a bit more thorough answers in disaster recovery automation blogs that are currently being written in Databricks. So please stay tuned. Please subscribe to Databricks blogs, and you'll get quite a lot of interesting insights on that.
Follow-up questions. So the challenge we have is always keeping the automation scripts up to date with all the changes which we are doing on a day-to-day basis. We keep running the grant statements, and so how do we ensure that the automation or infra is also up to date? That is a challenge we face today.
Yeah, so the question is, how do you make sure that automation on the infra is up to date? Well, use Terraform. You always use infrastructure as a code to manage your infrastructure, and you don't allow any manual changes to be there. You set a statement that if it's production, then it's managed by Terraform. And only that way you can enforce consistency.
So hello. First of all, thanks for the presentation. It was very insightful. So my question is the following. So throughout your presentation, you mentioned many times about creating tons of or different workspaces in order to guarantee isolation. So in our case, we are starting the data mesh journey. Sorry. we right now have like one workspace for the whole company. So my question for you is like, what, in your opinion, what is the best way, the way trade-off to create a workspace like in relationship with the number of projects? Like, it's going to be one workspace for the whole company, one per project. What is the good balance of number of workspace per, like, I don't know, organization?
Yeah, so essentially the question is about rules of thumb for number of workspaces in the organization. So my advice is to always start with single workspace and automate it, because well-structured monolith is better than microservice mess. Then, once you automated everything, you start realizing that, hey, actually, it turns out I have I know, billing department, I have predictions department, I have marketing department. And then you see that all of those departments need their own freedom. So what you do is just separate their jobs into 3 different workspaces: marketing, billing, and automation, whatever. So you add a new workspace per department. And the best number of workspaces is around, I don't know, 3, 5, because for more you have to pay a lot of overhead in terms of managing it. So do not overdo workspaces. If you are doing project-based workspace, you're probably an organization with 10,000 employees. And if you're an organization of 100 or 500, I mean, 1, 2, 3, 5 workspaces might be totally enough. But make sure to automate, because you can always grow it.
And to add to that, like we currently allow a very limited number of workspaces to be created in an account. And if you, this is to protect our customers. And if you want to go beyond a certain range, you would have to reach out to Databricks support.
Manish is from the team that manages workspace roles. So.
And does this work across the cloud providers?
So is your question about can you use the same Terraform code and port it from Azure to Amazon or GCP?
Yes.
The answer is you have to use specific resources like node type to pick cloud-specific node types. And most of the features between cloud providers in Databricks are working. There might be slight differences like spot instance setup or other things like that. But in most of the cases, if you don't use cloud-specific spot instance setups or things like that, it would be cross-compatible across many different clouds. So it really depends, but in 90% of cases, it does.
Thank you.
Hi, I think there was a slide on MLOps where probably, for example, we're using a centralized model registry.
Yes.
And I'm actually a little keen on understanding how do you go about registering models when you connect to a centralized model registry, because what we or I face challenge with is the token, because there's only one token, and that's the admin. And when others use it, the model gets registered by my name.
Yeah, so these modules set up service principals with on behalf of tokens, and they take care of keeping that all in sync. So these modules do the heavy lifting for tokens for you.
So when a model is registered, will it show the actual user who actually sent it? Because I do not want a lot of workspaces per user. You see, because if data scientist A wants to register a model, and because the connection to the model registry happens via this token, which is actually set up by an admin. So essentially, it's the admin's account which is registered as a creator. And that's my...
So in the case of our MLOps modules, it will be service principals accounts that will be registered as creator. And if you want to know more, you should talk with our ML productionization team and project managers for that, because they are looking forward to your feedback.
Yeah, because that's kind of a little important, because we want to know who created the model. Because otherwise, maybe if you have other ideas, maybe tagging or...
Tagging is a good way, yes. Yeah. This is the best way of managing it. Manish, we are like 35 minutes into the talk. Maybe one more question?
Oh, I get it? Thanks. So I'm sure your team all sets these up correctly, like just on day one. When you're talking to organizations that already have this mess that you showed on the first few slides, and they want to move to a nice automated system. What challenges do you see there, and how do you advise people to overcome those?
So the first and the biggest challenge is related to writing configuration. We solve it by Terraform exporter that is thrown into workspace and generates the config. And we just educate people by our field engineers to do things right. And that's essentially it. Thank you for your question, and I hope you learned something new today.
Yeah.